What if you could create a detailed 3D model of a building, a room, or any object just from a few random photos on your phone? Well, a new paper introduces an AI called Depth Anything 3 that is getting incredibly close to making that a simple reality. Welcome to Summarize Science, where today we're looking at a model that can recover the visual space from any view. As you can see in this overview, the goal is to take any number of images, with or without knowing the camera positions, and output a consistent 3D reconstruction of the scene. This is a huge step toward a universal model for 3D understanding. Traditionally, creating 3D models from images required complex, specialized systems for each specific task. But the brilliant insight here is the model's simplicity. Depth Anything 3 uses a single, plain transformer architecture, similar to what's used in large language models, without any fancy, custom parts. This single network learns to understand depth, camera position, and the overall 3D structure all at once. To handle the fact that real-world photos are often messy and lack perfect data, the researchers used a clever teacher-student training paradigm. They first trained a powerful teacher model exclusively on millions of perfect, synthetically generated images. This teacher then created high-quality training labels for the main student model, allowing it to learn robustly from real-world datasets that might be noisy or incomplete. So, how well does it perform? On a new comprehensive benchmark designed to test these abilities, Depth Anything 3 set a new state-of-the-art across the board. Looking at these charts, you can see it significantly outperforms previous leading models in both estimating camera poses and in the accuracy of the final 3D reconstruction. It surpasses the prior best by an average of over 35% in pose accuracy and over 23% in geometric accuracy. The visual results speak for themselves. Compared to other methods, the 3D point clouds generated by Depth Anything 3 are far cleaner, more geometrically regular, and contain significantly less noise. The depth maps it produces also capture finer details and are more semantically correct, as you can see in these side-by-side comparisons. The model is so versatile that it can also be used for other advanced tasks, like novel view synthesis. This means it can generate photorealistic new views of a scene from perspectives that were never in the original input photos. So let's recap the breakthroughs here. Depth Anything 3 shows that a single, simple transformer model can unify multiple 3D vision tasks, which is a major simplification over previous approaches. Its teacher-student training process allows it to leverage the best of both synthetic and real-world data to achieve incredible performance. This work represents a significant step toward creating versatile 3D foundation models, AIs with a fundamental and actionable understanding of our physical world. The potential applications for robotics, mixed reality, and content creation are enormous, paving the way for a future where the digital and physical worlds can be mapped and merged more seamlessly than ever before. That's all for today on Summarize Science. Thanks for watching.